Hello students. So today we will discuss some concepts and problems on atomic physics. So let's straight away take some formula from Bohr's theory. They are generally asked in your exam as well. So first let us see how they are derived. We all know that Bohr's theory is applicable to single electron systems only. And in a single electron system we have a nucleus and an electron is revolving around it. So example of such systems are hydrogen, helium plus, lithium plus plus, etc. So in all these atoms we have just one electron, and Bohr's theory is applicable to these particular type of systems only. Now in Bohr's theory we have a nucleus, and the atomic number of the nucleus is taken as Z. We have an electron, and the electron is revolving around this orbit, this nucleus, in say an orbit of radius r. So if the velocity of electron is v and the mass of electron is taken as m equals to mass of electron. So Bohr's theory simply says two important things. Number one, mvr is equals to nh upon 2 pi. And number two, E2 minus E1 equals to h nu. So just these 2 points are the key figures that Bohr stated. Now, if this electron is moving in a circular orbit, then this must be having a centripetal force. Anything that moves in a circle must be experiencing a centripetal force. And actually, electron is a negatively charged particle and nucleus is a positively charged particle. So there is an electrostatic force between the electron and the nucleus. So according to Bohr, and earlier Rutherford was also saying the same thing, that the electrostatic force between the electron and the nucleus will provide the required centripetal force. That simply means force of electrostatic attraction is equal to the centripetal force. We call the same force as centripetal force, and this force is actually electrostatic force. Please do not confuse it like two different forces acting simultaneously. It's just one force, which is electrostatic force. We are naming it in two different ways. So one name is electrostatic force to the same force, and the other name is centripetal force, because this is the only force which is acting towards the center of the circle during the motion of electron. So if we apply Coulomb's law, so Coulomb's law say that 1 upon 4 pi epsilon naught Q1, in place of Q1 we will write ZE, charge of the nucleus, into charge of electron divided by r square, radius of orbit, and for centripetal force it is mv square upon r. So 1 power of r can be cancelled with 1 power on the right hand side, and we simply get r equals to ze square upon 4 pi epsilon naught into mv square. We may further write this equation in a better manner if I write it like equation number 3. So instead of doing this, we can rearrange the term like ze square over 4 pi epsilon naught equals to mvr into v. I am writing this on the basis of equation number 3 directly. So if I do that, then earlier I told you that in equation number 1, mvr is equals to nh over 2 pi into v. So this is ze square upon 4 pi epsilon naught, and if I solve it, v equals to ze square upon 2 nh epsilon naught. So we have got the velocity of electron, and over here you can clearly see that v is inversely proportional to n, rest all terms are constant. Z is number of protons, which is a constant, E charge of electron, which is a constant, H that is Planck constant, epsilon naught that is permittivity of free space, and 2 is a number. So this clearly implies that those electrons which are closer to the nucleus are moving faster, and those electrons which are away from the nucleus are moving slower. Now, if we put this value of velocity in mvr equals to nh upon 2 pi, then we simply get m into ze square over 2 nh epsilon naught into r equals to nh upon 2 pi, and this simply means r is equals to n square h square epsilon naught upon pi m z e square. That is the radius of electron orbit, or radius of a stationary state. Clearly it shows that r is proportional to n square. Means if we simply make a table where we write n is principal quantum number or the label of orbit. The innermost orbit is n equals to 1, which is also known as ground state. The next orbit to is called first excited state, which is n equal to 2. Next is second excited state, n equal to 3. Next is third excited state, n equal to 4. Next is 5. Next is 6, and next is 7. So if the radius of innermost orbit is r naught, then it should be 4r naught, 9r naught, 16r naught, 25r naught, 36r naught, and 49r naught. Provided we are talking about the same atom. For example, if this is the case for hydrogen atom, the ratio will remain that. Now it can be asked that what is the ratio of first 3 stationary states according to Bohr's theory. So the answer will be 1:4:9. If I ask you what is the ratio of the radius of first excited state and fifth excited state. Now first excited state is n equals to 2 and fifth excited state is n equals to 6. Over here the radius is 4r naught, over here it is 36r naught, so the ratio is 1:9. So imaginarily, if we consider that the first excited state is having a radius of 1 meter, then the fifth excited state will be having a radius of 9 meter. So we have determined the radius, we have determined the velocity. Now if I ask you what is the kinetic energy. So kinetic energy is half mv square. We have already calculated v, so we will substitute it. ze square over 2nh epsilon naught, that was the expression for velocity. If we square it, this will become mz square e to the power 4 upon 8 n square h square epsilon naught. So this is the kinetic energy. If I ask you what is the potential energy, so potential energy generally denoted by U, and in electrostatics we have studied potential energy for a system of charges is given by this formula. Over here Q1 equals to the charge on nucleus, which is the positive, Q2 is the charge of electron, which is negative, and R is the radius, which we have already calculated, n square h square epsilon naught over pi m z square. So if we substitute all these values, we will get u is equals to 1 upon 4 pi epsilon naught Ze into minus E. Remember, whenever we solve problems on potential and potential energy regarding charges, the symbol of charge is necessarily considered over pi m z E square. Sorry, substitution is slightly not correct. Over here it is n square h square epsilon naught over pi mz E square. So potential energy is turning out to be negative, and this pi and this pi cancels out. So m z square e to the power 4 upon 4 n square h square epsilon naught square. That is the potential energy. Now if you see the expression for kinetic energy and the potential energy, mz square e to the power 4 upon 8 n square h square epsilon naught. The kinetic energy was mz square e to the power 4 upon 8 n square h square epsilon naught square. This was kinetic energy. So all terms are same. Kinetic energy is positive, potential energy is negative. In the denominator, potential energy has a multiplier 8, and in the denominator, potential energy has a multiplier 4. That simply means potential energy is equals to minus 2 times the kinetic energy. That is a very, very important result. And if I ask you what is the total energy? So if total energy is E, it is kinetic energy plus potential energy. Because we have already written that potential energy is minus 2 times the kinetic energy, so you can say it is negative of kinetic energy. That means total energy is minus mz square e to the power 4 upon 8 n square h square epsilon naught square. So we have got some very important result. We have determined the radius, we have determined the velocity, we have determined the potential energy, we have determined the kinetic energy, we have determined the total energy. And because the total energy is negative, it means electron is in a bound state. Bound state means it is attracted to the nucleus and it cannot leave the atom without the help of an external agent. If an external agent provides this much energy to the electron from outside, the electron can be freed from the atom. Now, after all this, we can solve some simple problems. For example, problem number 1, find the radius of first excited state in helium plus if it is R naught in ground state of hydrogen atom. Now this is a very easy question provided we know the expressions. So first thing is we have a hydrogen atom, and for hydrogen atom Z is equal to 1. For ground state N equal to 1. And for these things radius is R naught. Now for helium plus, we are talking about first excited state. So for helium plus Z is equal to 2, and for first excited state N equals to 2. Now we also know that R is proportional to N square. The expression was R equals to N square H square epsilon naught upon pi mz E square. So over here z is also changing. So we have to write n square over z, and based on that we can simply write r1 upon r2 equal to n1 square upon z1 divided by n2 square upon z2. And if we solve it, it will become n1 upon n2 whole square into z2 upon z1. Now n1 is 1, n2 is 2, z2 is 2, z1 is 1, r1 is r0, r2. So we can determine r2 is equals to 2r0, and that is your answer. Next question, determine the kinetic energy and potential energy of electron in third excited state of hydrogen atom. Again, this is a very important question. For hydrogen atom, we have already determined that the total energy is minus mz square e to the power 4 over 8 n square h square epsilon naught square. If I substitute all the things, because m is mass of electron which is known to us, z is hydrogen atom, for hydrogen it is 1, e is charge of electron which is well known, h is Planck constant, 8 is a number, and epsilon naught is the permittivity of free space. So if I simply solve it, then it turns out to be 13.6 upon n square into z square electron volt. So you can remember this detailed expression, and for numerical purposes this formula will be highly helpful for you. Now, according to the question, we are talking about z equal to 1 because we are taking hydrogen atom in consideration. Also, we are talking about third excited state. So third excited state means n equals to 4. So if I substitute these two values, the total energy will be 13.6 upon 4 square into 1 square electron volt. That means 0.85 electron volt. That is the total energy. Now, we have earlier proved that total energy is equal to minus 1 into kinetic energy. That simply means kinetic energy will be equal to 0.85 electron volt. And as far as potential energy is concerned, potential energy is minus 2 into kinetic energy. So it will be minus 1.7 electron volt. And that is your answer. So this is again a very important question. There are many other questions. Do refer your PYQs, solve them. Thank you. Thanks for watching.